on with designing our Deco, or our Strymon small box MIDI mod project, a replacement control board for your Strymon small box pedal that enables full MIDI control connectivity, built-in wireless MIDI over Bluetooth, all sorts of stuff. So, going to crack on. If you're just tuning in, you're not sure what's going on, then check out some of the previous streams. Lots of good information on there. And this is basically a really good intro to, I think it's hopefully good, to PCB layout and design, schematic capture, all that good stuff. So if you'd like to get started with electronics design, then this is a great place to look. We're using Fusion 360. Not an ad, not sponsored by them, but we're using that for its, fairly open license for hobbyists. And if you'd like to get started with, combining electronics design and manufacture with some 3D modeling and things like that, it's a really good place to get started. So not without its quirks, that's for sure. But without further ado, let me just bring up our project files and we'll switch over to the main window here. All right. How's that? There we go. So, last week we got most of the PCB routing done. So we'll go back over to our control board here. Well, we got some, I should say. Some of our PCB routing done, and we've been routing our critical signals, so things like our USB differential pair lines here. We've been routing our quad SPI flash, looking at some general rules of thumb and things like that, and best practices in PCB design and layout. And things are coming along quite nicely. All right, so I'm just kind of catching up after a week away from this. So we've got our DAC routed here, our digital to analog converter, which takes PWM outputs from our RP2040 microcontroller and converts them into a very specific range of analog waveforms, perfect for sending to the the main board there with the DSP controller. Got our power section here. So what we might do is just continue on with some of this. We need to route our V in here. So we're just going to kind of finish off this power section here. So using a nice thick trace here so that we can avoid any. And these thick traces, by the way, we're dealing with very, very small amounts of current. So it's not for any current handling capabilities, but it's to decrease the resistance of the overall trace in DC, because we know that any Ohm's law tells us V is equal to IR. So the voltage across a trace is going to be equal to the current flowing through it, multiplied by the resistance. So if we can lower the resistance, then we get a lower voltage drop, which increases our working voltage, and headroom available for that supply rail. So we can use a nice thick 24th hour trace there up to our V in. And let's take a look at the sort of state of things. All right, so what we might do is get these PWM signals over here, connected up to our RP2040. And again, my preference is to use 8th hour traces whenever possible, and we did some sort of playing around with the best combination of what traces to send where. But yeah, using 8th hour traces wherever possible so that we aren't pushing the manufacturing tolerances of our PCB house too much where we can avoid it. So what we might have to do is move this sort of the increase of that thickness trace back a little bit so we can escape out this trace here. All right, so we might go through here. Now, technically speaking, it's not the best idea to be running traces underneath this bypass capacitor. So you can see if we go under here, it sort of depends a little bit. We've only got a very low power PWM signal, but it is going to be switching fairly fast. And so to avoid any potentially artifacts from that coupling to our clean supply line, we're actually going to go around that decoupling capacitor there to get to our to get to where those signals need to go. All right, so we can pretty much just route these out and over now because we spent a bit of time being careful with our placement. Like I stressed on last week, time spent perfecting your placement will save you a lot of time in your routing. So let's bring that up here. All right. Lovely. Lovely. Probably bring that a little bit closer. To be honest, it probably wouldn't cause too many issues if we did run that trace underneath the decoupling capacitor, but I haven't actually worked with the RP2040 before. I don't have any sort of personal history in terms of really how rigid those supply lines need to be. So I'm just going to follow some best practices. It's not really going to impact my layout that much by just avoiding that. It's only one trace width up there, and being able to just do everything I can to make sure that I get a really nice working board the first time is gonna save some headaches later on that to be honest can easily be avoided. So all right, I'm going to attach the decoupling to this our ADC chip here. So again, we're using probably use some 16 or maybe 20 thou traces so we get some nice low impedance. In fact, I'll use the same width as that pin, so nice low impedance traces here to our supply. We've got these separate, even though these are connected to the same signal, because one of them is the decoupling for the analog rails and the other is the digital rails. We want to keep them separated until they go sort of tie back to a reference plane or back right to the 3.3 volt regulator there, just to make sure that we're not introducing too much noise or sort of crosstalk in there. All right. This is looking good. We didn't really place those components there before, did we? These current limiting resistors for our LED inputs. So they're just reading the LED signal from the the main board, just in case it might send some sort of analog waveform that we might want to monitor rather than just a digital on or off, which is why they're going into our ADC channels, and it's a good thing we've got those spare channels. We could, of course, use the onboard ADC for those onboard ADC on the RP2040, but given that there's not enough channels anyway for all the pots, so we need to use that external ADC, it makes sense to me to just use that ADC for everything, and then it's one less peripheral that we have to enable on the actual RP2040 itself. So, all right, now we're taking a look at how things are traveling. This connector here is looking fairly well routed. We're going to have 3.3 volts in ground. Then the only other thing we need to add on here is this VBus sense pin. So probably going to need to route it up and around, but it's going to be very low priority. It's basically just a DC line to detect whether there's the presence of a host connection or not. So you can ignore that. I'm going to go ahead and do these our RGB LEDs, addressable LEDs. So we're going to run the decoupling to those. All right. And we're going to I still haven't decided whether we do a ground pour on this top or not, whether we go 2 versus 4 layers. So, yeah, I mean, it's probably... We'll leave that for now. We'll cross that bridge when we get there. All right, but the data out from this LED, send it up here and away. Try and avoid that really sharp corner there. All right. Now, one thing I do want to do actually is I'm going to take out this small 1616 RGB LED and just put three individual LED footprints on there. And the reason being, I don't really use sort of this type of LED in many designs, and so we don't actually have that LED loaded up on the pick and place machine, but we do have some individual 0603 LEDs that we use all the time. And this is not going to be visible, so the RGB-ness doesn't really matter. It's just there really for checking our prototype and debugging or things like that. So we'll go back to our schematic here. Let me close that side pane so we've got a bit more room. And where is our... Let's bring that down a little bit. There's our MIDI module. Here we go. I'm going to delete that. Okay, and instead we're going to place a standalone LED. I'm not really too worried about what color they are. We're just going to place them there, and that looks pretty grotty, so we don't really need that value there for them. We might just move the designators so they're a little bit easier to read. Cool. And then we can... All right, we'll tie all of those to 3.3 volts as common. Cool. I'm just going to move those designators there a bit to clean it up. All right, great. So switching back to our PCB now. Those LEDs are down here. All right. All right, they can probably just go. I mean, kind of just gonna rip these traces up here, so I can sort of place these a little bit neater. To be honest, it's a little bit messy what's going on here. So that resistor is for this LED. So I'm just gonna kind of organize these so that the relative or relevant components are next to each other and organized as neatly as possible. Something like that I think will work quite well. Let's keep some nice consistent spacing there. And we might as well center these, I guess. For neatness sake, there we go. Okay, now let's route those traces. So again, very low power. These LEDs are not drawing much current at all, only a couple of milliamps. All right, now this LED serial data signal, we might, switching back to our 6.25 thou grid, we might actually might run it up. I'm not really too worried about routing under these decoupling capacitors because they're much, I guess they're just a lot less important than the decoupling capacitors on our the actual microcontroller core. Don't need to worry about this copper clear here. This is just a footprint for the onboard PCB antenna version, but we're going to be using an external antenna so that the signal can get out of the metal enclosure here. And now we can just run these drive traces down to here. And I'm just going to run these in parallel because I'm not worried at all about any crosstalk or coupling. They're just LED traces, not really that important, and just kind of makes things a little bit neater, keeps them streamlined. Oh, went too far down there, didn't we? Lovely. All right. Get those up and out of the way a bit. Okay. I'm just going to make a bit more room for that 5 volt line there in case we need to escape that out in this direction to connect it to the rest of the 5-volt power. There we go. I'm going to might as well keep going with the LED data routing while we're on it. Okay. Fantastic. And then this one's going to come. All right, we might bring it up and around here. This is a very low frequency signal. We don't have to be too worried about kind of being pedantic about the way we route it. The important thing is just to keep it's still a digital signal. So if we can keep that away from our analog lines, then that's really going to help things. All right. Probably do something like that. Then this is going to come, this trace will come out there. I'm going to move that out of the way a bit so I can, that decoupling cap should be over the other side. So it's right next to that 5-volt pin. I think I missed that when I rotated the LEDs. All right, we'll put it there. And we're just going to use a slightly thicker trace. All right, just as a general rule of thumb, I like to use 12 thou traces. For these they're still really low power. Like these LEDs are drawing less than 100 milliamps at max brightness. I think something like 60. Typically they're drawing within the neighborhood of 15, 20 milliamps. So very low power. But this is just best practice, and it's going to perhaps you really just get unlucky with the tolerances on your components. You get some right on the edge. That's just going to help alleviate any potential issues that you might have, as well as just teaching some best practice in your layout. This LED trace, I'm probably just going to run it all the way down here to keep it out of the way. Because again, it's not really too critical. You're not going to come a guts or have any main big blowouts with your signal integrity with these LED lines if you do something like this. All right. Just going to help keep these out of the way. The main thing is trying to isolate them from any critical analog stuff that we have going on. All right, again with this, I'm just going to move this decoupling cap up here so it's nice and close. Lovely. All right. And then this LED is being fed from our microcontroller. Okay, so we're just trying to look for really easy, like low-hanging fruit that we can route out here, and yeah, so we might as well start on the analog signal from our pots now. This one's going to be a bit tricky here, getting the LED data down to this LED without sort of intruding on that analog signal. Analog signal is going to have much higher priority in terms of caring about the importance of that trace. So we're going to route it first and sort of do everything around it with respect to that signal. All right, we might come down here and sort of come to about there. Then we're going to go down to our bottom layer. So we're going to run a via. We're just going to use the default via size. We don't need to go too small. We're going to bring it down, keeping nice and out of the way of the rest of those traces. Like so. Lovely. Get that 5-volt power there while we can. Okay, then we've got this potentiometer coming up to here. And we've got this pot here, and last one all the way over on this side. So this is going to be a little bit interesting. We're probably, for this pot, we're going to have to run down and sort of around somehow while trying to avoid these signals. But these are very low frequency. You know, these are only just status lines. So they're not actually like, high speed data or anything like that. So we can kind of route these more or less wherever we want, and we don't have to be too concerned with the performance or anything like that. So, just give ourselves a little bit more space here. All right, lovely. Yeah, that analog line is going to take priority. That's for sure. These lines here are JTAG, are part of the JTAG and debugging interface, and so they're just exposed to those test pads so that in production we can flash them there. And then we've obviously got our UART RX pin there as well. So these are the debugging UART pins. We're not being too particular about how we route those signals. They're very rarely used. Okay, this is looking good. Save that design. I'm just going to get a drink of water quickly. I need my glasses on. Thanks, mate. Okay. All right, so this is starting to take shape. Dan, hey mate, pretty pimping that jumper. Yeah, this is an Audi. It's a bit of a guilty pleasure wear, I must say. Super comfy and warm. I was that guy who made fun of people walking down the street in their Audis. It's just like, oh, come on, you know, is that what we've come to? And then I got one for my birthday, and very quickly realized that I was just a dirty hypocrite. They're so comfy and warm, and I frequently will walk my son to daycare in the Audi through the estate. It's a great time. Great time. All right. Sort of working out what to tackle next so we keep things as sensible as possible here. I think I will make this a 4-layer board in the end. Well, I'm ignoring about it. Definitely going to make it a 4-layer board, I think. So it's just going to help keep things, much tidier. So we're looking at some 4-layer board stack ups. I think I was talking about that last week, and we're basically just going to go kind of our signal on our outer 2 layers, then power and ground internal. It's not the most ideal, in terms of like EMI performance, but it's going to be more than good enough for this. What we're going to do is the layer right next to this top signal, so layer 2 is going to be our ground reference plane. So all these high-speed signals have that ground reference plane directly underneath them, and then we can use the bottom layer for routing, just very short traces like this one, or bits and pieces like 5-volt power lines and things like that. You're wearing Crocs too? No. Oh, well, no, I'm not wearing Crocs. I am wearing some Birks. I actually got these. They are rubber Birks, and so unlike the cork kind of ones which get really grotty and sweaty and gross, these things just are indestructible. I wear them mowing the lawn, wear them to the beach. You give them a wash and clean them up, and they look really nice in summer. Terrible for anti-static. I've got to be really careful that I don't touch anything. Got a big like synthetic static accumulator here, and then insulating rubber Birks. You pretty much just touch something and it gets instantly shocked, especially in winter when it's a bit drier. So fortunately we don't live where it's too dry, so the air's not too bad, but looks definitely not ideal. Definitely not ideal. All right. Okay, where to? I think we're going to bring these bring these lines down a little bit, at least just kind of escape them out from our module. We can make sense of some of these air wires. What are you up to this morning, Dan? Not too early for you, I suppose. All right. So I'm going to hide these 5-volt lines because we're going to route those as part of the power, part of the power layer or on our bottom layer, either other. Probably should do these decoupling for the for our Bluetooth module. Not strictly necessary because the module will have decoupling on board. In fact, I'm actually going to get rid of. No. So there's just 100 nanofarad and then a 4.7 microfarad capacitor on there. It's probably not that necessary, but it is going to, just going to help, not guarantee, but sort of guarantee the performance of the module. So now that I've remembered what stack up we're using in terms of that 4 layer, I'm going to start dropping some V's down for our 3.3 volts because we're going to have a 3.3 volt reference plane on one of our internal layers. So I might also, because we need to grab this, this is the TX line for our Bluetooth module. I'm going to bring that down here and sort of bundle it into the rest of these signals here. We can run traces through here, so that's pretty handy. We'll definitely want to switch to some 6 thou traces just so we don't get too close to those pads, but we'll bring them down as far as we can. So that's going to be nice. So, all right, we'll switch to some 6 thou traces. Bring it in between these pads. All right. This is all looking pretty good. You're working from home while I'm playing on the TV. Very good. Are you like a YouTube on the side screen kind of operator? Are you doing some work? I definitely find that. I think working as obviously I work from home. As a fairly extroverted person, I almost have to have something just playing in the background. Like either some what's a good one? Some Lions Tech Tips, or even like some Fox Sports or Bloke in a Bar, Hello Sport podcasts. They're some of my favourites. Bit of a footy and a rugby league nut here. It just helps when you're working from home. I don't know, it just helps me feel a little bit less like by yourself day in, day out for the whole day. But yeah. All right. It's got this analog signal here. I'm just umming and ahhing, like kind of is a bit more prudent to run these signals here on the top layer so we don't have to run 3 grounds, but I want to keep that analog signal as like close to that reference plane as I can, I guess. Honestly, it's such low frequency. It's not like an important analog signal that it makes more sense to via this and run that on a bottom layer. So that's what we will probably do. And then we can also, although the only thing is we're going to have to change the order that these traces come into our chip. What lines do we have here? So status 1, status 2, and button. So UART1 TX has already got to go down the bottom. So in fact, it probably didn't make much sense to route it down here like this. Should have thought about this a little bit earlier. I'm going to change the order that these are connected to the microcontroller so we can kind of connect them up without having overlaps. Okay, so all right, so we want to swap those two. So what are they? There are status 1 and status 2 lines which are coming from the module. So now RP2040, I'm just going to swap these. Usually ABC News going, okay, bit of an ABC News kind of operator. Fair enough. I almost can't remember the last time I watched free-to-air TV, or a streaming variant of that. Okay. Probably bring that down there. And again, these are such low frequency that these traces can almost, you can run them however you want, and it's not going to impact the performance of anything at all. So don't have to be too concerned about things like that. Just going to route them in a way that's kind of clean and makes sense and avoids causing too much confusion. Oh dear, the invading toddler. Hugo, Daddy's working, buddy. Funny little charm. Then the buttons crossed over all of them, so I'm going to have to reshuffle that after all, unless there's a spare pin there. I can just... Yeah, I'll just chuck button on 38, and that saves me having to kind of muck around with that. Okay. So, Dan, what like ECAD software do you use for your looper project? I haven't actually checked out the PCB or schematic files yet on the GitHub repo. I just had a peruse of some of the rest of it, but I haven't looked at sort of the hardware manufacturing files yet. And the sooner the industry sort of can standardize, like .brd and .sch file formats, the better. It's such a pain sometimes because they're just text files. Like, there's not that much to them. I get the library, kind of libraries are starting to get a little bit tricky and where some of the issues come in, but honestly, it's not that bad. Use KiCad or KiCad. Yeah, nice. Are you on KiCad? Are we on KiCad 7? I believe KiCad 7. Yeah. Been on KiCad 7 this year. How are you finding it in comparison to version 6? I hear that it's just sort of leaps and bounds, and it's a really, really usable product, especially with V7. Okay, this is looking pretty good. So one thing we want to be cautious of here a little bit is we've got this this trace here. Now, going back to our schematic, I probably should label that because it's a little bit unclear. So this is V. I'm just going to label this as VREG in. Put that there. And this here is VREG out. Bad practice. Should have labeled those in the first place so I can see what those traces are in our PCB. So VREG out has to connect over to the other side here. Now, whether we do that on the power plane, I'm not too sure because, where this section here of the power plane, obviously we don't want to run anything in between that ground pad, so we can run a nice connection to the ground plane. I don't know whether we run that on the power plane section over to there. Probably, not a bad idea. Only learned it a few months ago, so we went straight 7. Yeah, cool. How do you find the built-in libraries? Because I feel like that's one of the... I perceive it to be a strength of KiCad is that the built-in libraries seem to be quite good and robust, especially with supported 3D models. Is that something you've found? Okay. What are we going to be running? Trying to work out what to route next so we don't get in too much of more of a rat's nest than we already are. Okay. Potentially an oversight here. I haven't run this button for our quad spy, and it needs to go up to there. Okay, that's all right. Less than ideal, but what we'll do is just run it to there, and drop a trace down. Get to our quad spy. Chip select pin there. And this LED data is probably going to have to be the same. It's really frustrating that it's all the way over there, but that is what it is. Library's okay. I had to build a few footprints. Yeah, that's to be expected. Pretty much any PCB software, you're going to be building footprints. That's the longest part of PCB design, really, is building footprints. What I am wondering about is whether I want to run. No, I don't want to flip that. I'll keep that on the top layer. But this debug connector here, the tag connect cable for it arrived. I'm sort of transitioning using that as my programming header. And it's here. Let me go to sort of full camera. I don't know how well you can see that, but it's really nice. Cost an arm and a leg. I think this cable was like $55 Australian or something like that. Crazy times. But it is really nice. So on a board here, this is the current Aero prototype. It's got these guide pins which you can see. We'll go back here. These holes here are for these guide pins, so it can only be inserted one way. Then the actual signal connectors are spring loaded, and it's got these larger holes here for these locking tab legs, and so you can just sort of push it in, squeeze it in, and then it's attached. It's not going to come out, not going to come loose. You get a really solid, reliable connection no matter which way you wiggle it. Really nice. And then you can get this, of course, without the locking legs. So if you were doing this in a production line environment, you can just sort of push it down, program. When you hear the beep, take it out, and away you go. So yeah, really like that connector. It's super nice. Like I said, the cables themselves are not cheap. But the beauty is that you get this for free on your PCB. It takes up very little real estate, and you also then don't have to pay the cost and hassle of a connector for your debugging interface. So that is really nice. Let's escape this. Debugging lines here. Kind of bring these up and around to the top. And bring them down. Let's get them away from those holes there. Lovely. Yeah, this is going to be a bit of a mess, isn't it? I am going to go ahead and add in some vias for these signals. So what we're going to do, because it's a 4-layer board, we're not going to do a ground pour on this top layer, because it's only going to add to the thermal mass. It's going to sort of reduce the control that we have over our return lines. And we're going to have that big solid ground reference layer in the middle there. So just switching to our 12th hour trace, we're going to give each of the individual signals their own sort of via to ground. And we're going to make sure we don't put any of that via in the pad here. So our crystal, I'm actually going to move that load capacitor so that the ground is closer to the crystal ground. Should have done that in the first place. So that can be there, nice and close. There we go. Yeah, for anyone looking to sort of implement like a debugging connector, or even just a test connection, like if you're doing audio stuff, this is really nice because you could have power, if it's a low power circuit, power, ground left and right, or it's got 6 pins. You can get 10 pin ones as well, or you can get bigger, larger pin pitch as well. You could do like left and right, differential audio, coming out of like a balanced signal, all sorts of stuff. They're really, really great. Okay, how are we traveling? Okay, so what I'm going to do is kind of just use like a ground flood here, or a sort of a localized ground plane for this crystal oscillator here. So, and then because I want that all to be connected with really nice low impedance ground connections, and then just tied to that reference plane at a single point, likely, that pin there. So we're going to add a couple of vias. Can I add some there, nice and close there, and there. I'm not really going to worry about any via fencing or anything like that. You could, but I don't think it's going to be too necessary for this. Okay, so put our thermal width. We'll leave that at 6. That's fine. Okay, where are we going to run this to? Kind of just get a shape down first, and then we can sort of fiddle with exactly where it's going to go. I'm only going to really run it to here. I just want to get just want to get something down. We're going to turn off thermals for this because it's only a very small amount of copper, so we don't have to worry too much about the thermal performance of it. And we'll add a little bit of isolation there just to keep it away from some of those critical signals. I guess the other, we could always just run a trace from there to there, but not really that important which way we go about it. I'm gonna clean that up a little bit there. If we wanted to be a bit more pedantic about this, we'd run it sort of like that. In fact, we might, just for the sake of cleanliness, so you can see how you might run a more complex geometry polygon. So here, so we're going to run it kind of down to here. In fact, we might run kind of down here, and to our flooding this area, making a really nice low impedance connection here. And there's different ways you can go about laying out these crystal oscillators. There's trade-offs to both. Again, I'm not really putting in too much time into nitpicking over this. I'm a little bit, but not too much. Just because it's, for this application, the performance is going to be just fine. Again, we want to turn off thermals. Yeah, and we get a kind of it's no different to, running big, thick traces to there. But it helps keep all of that nice and kosher. And we'll probably go and add a silkscreen outline to, pretty up the board a little bit. And we'll end up using these kind of mini ground pours quite a lot in this design to sort of tie localized ground lines together and then connecting them sort of at a single area or point to that main ground plane there. All right. This UART line, didn't really solve that, did we? What we might do, where's it coming from? It's this pin here. I'll actually take a look at it at the pin level. So we've got our TX and RX pins both need to go up that way. And then we've got these are going to the connector. So I'm going to need to jumper the sort of switch down to a via to get past this anyway. So I'm going to run our TX and RX pins, keeping on the top layer, over to here. And again, if you wanted to be really pedantic about this, you wouldn't run these lines in parallel because then you might get coupling across them. It's UART, it's really low speed, it's not going to be a problem. We don't want to go near there. We don't want to run. Basically, we want to avoid running anything under there. We just want ground reference plane under there. You don't want any traces going underneath there. So we've got room to route them down and underneath. We'll just move these DAC lines down a bit so that we can maintain some spacing between our analog and our digital signals. All right. And in the KiCad libraries, Dan, did they all come with ready to go 3D models, or have you played around much with the 3D side of it? I'm just interested to know. I follow it fairly closely and have a reasonable idea of where it's up to. I just haven't had as much hands-on experience with that side of things. I guess those would be the questions that I would have. So it's interesting to ask someone who has done a project, obviously in this sort of area as well. I am going to switch these to 6 thou layers, not because we strictly need to, but I would rather sort of have that compromise and be able to have a bit more separation away from that, those oscillator lines. That is definitely the lesser of two evils, because you'll see how much space we end up saving. So how much extra separation we can have. And then I'm also going to leave a bit of extra separation from the UART lines to the DAC lines, so that those analog signals also have some separation to them as well. We'll bring that down and out of the way there. All right. Cool. So yeah, a little bit of separation there between our UART and our analog signals, which is always nice. And then just a bit more room away from that crystal area there. All right, I'm going to bring these back to being 8th thou traces pretty much right away. And up and away we go. We could have gone to the bottom layer there, but we didn't really need to. We were able to, with a very small compromise, stay on that top layer, and then we are going to be able to preserve that area of the bottom layer because we're actually going to need a fair bit of bottom copper area to run all those traces. I don't want to get them too mixed up if I can help it. So here, there's no two ways about it. And if you remember, I was saying the trick with designing a good multi-layer board with SMD components is to treat it like a single layer design. Within reason, obviously, you don't want to be doing that if it's going to be putting in, kind of bad design elements to your PCB layout. But within reason, for all these non-critical traces, yeah, if you can treat it like a single layer design and route as much and do your placement as carefully as possible to sort of reduce overlap between traces and things like that, you're going to come out with a much better PCB layout in the end. Okay, so might keep that on the on the bottom layer and kind of cross it over so that these, because we kind of need to cross those over a bit like that. All right, now we've got our analog signal there. It's going to have to go on the bottom layer. Sort of is what it is. All right, we'll probably just run this up to here. Got a fair bit of space here to route our signals, so I'm not being particularly careful. We can go and clean up the geometry of our traces and make things a bit neater later on if we so desire, but no real need to just as of now. Cool. Get rid of that stub. All right, this is looking pretty good. We've got you can probably bring our serial wire debug lines over. Going to be running that analog signal on the bottom layer anyway, so sort of a lost cause at the moment of keeping that on the top layer, so we might as well run these SWD lines here anyway and reduce the number of vias, because the more vias you have on the board, a couple of impacts. One, the more it's going to break up your ground plane. Every hole going through there is a little discontinuity that your signal has to sort of avoid. And it might not seem like much, but it's all going to add up. And so just where possible, you want to try and minimize breaks in that ground plane. And I'm crossing these at 90 degrees there so that the crosstalk is reduced, because parallel traces are going to couple to each other. That's sort of the worst case scenario, the maximum coupling that you get. There's a bit more of a scientific formula behind it, but if you think about it, you just want to think about the surface sort of area that is shared between those. And when they're running in parallel, you've got all these surface areas, these parallel surfaces. Whereas 90 degrees, that's literally the minimum that you can get. So it's just the way that I like to think about it. All right. Probably time to bring these down onto our bottom layer, I'd say. Like so. Yeah, I haven't touched any of the 3D stuff. Yeah, I mean, if you don't need to, then you don't need to, though. Although I'd highly encourage you to give it a go because, especially for one-off projects where you want to, you sort of just, I mean, yeah, I really like to visualize things in the 3D space and make sure everything's going to fit and sort of spend the time playing around with it there, so that I've got a pretty well-educated guess as to whether things are going to fit together properly or not. So same approach here. We're going to have to cross these signals over so that they go into our RP2040 sort of without overlapping. Oh, not meant to do that. Okay. Now, potentially problematic is we're going to have to go down there. So actually, what we might have to do is we're not going to overlap those because you'll see why. I'm going to have one trace going down there and then another one, because it's so close, another one coming in behind there. So we're not going to have to overlap those at all. We'll see how that sort of plays out in just a minute. All right, again, gonna bring these up and take them to 6th hour traces. Cannot be helped here. We need to avoid that decoupling capacitor. Like so. And this line. Oh, I needed to run the reset line with these as well. I knew I was forgetting something. All right, looks like we're going 6th hour traces all the way. That's not what I wanted to do. I wanted to change the width. Let's rip those up. All right. Okay. Dang, I forgot about that reset line. So that's going to have to come up as well. Okay, can we squeeze those out? Oh, barely, but then we're not going to have... Oh, I suppose the toggle can run as a via underneath there. Yeah, I'll be able to escape that out. That's fine. Curly thing is going to be these PWM lines, so we'll move those up. All right, so we can give ourselves a bit of space here. Need a little bit more space, as it turns out. And again, these debug signals are only going to be used for programming or debugging, so we don't have to worry too much about crosstalk from those or things like that, because they're going to be so infrequently used that they're not actually going to impact on the performance during runtime at all. All right, get that down to there as a 8th hour trace. Yeah, I forgot about running that reset line. What a pain. All right, well, let's... guess we're gonna be just running it there, I suppose. All right. Need to make a little bit more room around here. It's a bit cramped. All right, and then that's going to have to go sort of up and into there. So we'll move these traces up and out of the way. Put our via in there, and away we go. All right. Clean that up a bit there. Cool. We can come back and clean that up later. It's not the prettiest routing at all. Certainly isn't. But it's not terrible. Like I said, we can fix that up later if need be. So it's good enough for now. It gives us an idea of where our signals need to go, kind of overlapping that stuff. We've got these toggle lines from our switch, so need to get those down to our micro. Hang on, what on earth happened there? You're going just to that corner there, so I'm gonna have to run some vias. We'll sort of prepare for how we're going to run those. Okay, you need to run in between these pads, so we'll up and away here. It's going to be a bit quicker to actually to go from here. Welcome if you're just tuning in. Welcome. Leave a comment in the chat. Say hi. If you're working on any projects or anything like that, let us know. Definitely love to hear what projects you guys are up to, or if you have any comments or questions about any of this design process. Please leave it in the chat. We can discuss it together, because that's often the best way to learn, I find. Okay. Cool. Now we've just got to run these traces over to the other side. I'm a little worried about room for vias. This is getting very, very squishy, but what we might do is go back to our 6th-hour trace and sort of then run this up to the side like that. So we've got this room in here. In fact, we don't need to do that. We've got room. We've got that was a good idea. We've got room sort of underneath the chip there to run a via, so no worries at all. Plenty of space. Again, we're running these at 90 degrees to all of these other traces, just to, to best practice, reduce crosstalk where possible. And this guy's gonna... Ooh, this might be getting a little dicey. We're gonna have to employ the same trick, I think. Sort of running it down like that to keep it tucked out of the way. Ooh, I don't love that. Don't love that. Put that on the grid there. All right, let's ignore those violators because they are being a pain. There we go. No violators. Lovely. Every now and again, Eagle just gets in a spin and just doesn't let you do things because it thinks that its way of ignoring the violators is the best way. So we're going parallel across those. Again, it's the reset pin, so I'm not too concerned about the performance of that line. And it can't be helped. Not the end of the world. Can't be helped. Okay, so this is kind of coming together now. We've got a lot of this side of the board routed. It's some of this messier side here that we still need to work out. Just give me a second to double check something. Okay. All right, let's press on. Let's press on. What else do we need? Probably should get these signals over to our connector before we do much else, so that we don't find ourselves kind of short there. Okay. Let's have a think about this. So going, what's that line there? Foot switch 2. Okay. We're going to run that because that's a nice, easy one just to get out of the way. It's very low frequency. It's not kind of, probably the least critical trace on this whole board, I'd say. Those foot switch lines, we're just going to run it on the bottom layer. Where we can. In fact, I'm going to run it up, down here. Yeah, and then we'll run that trace. Okay, then lead data, got this toggle line. So yeah, we're just going to run all these kind of, low frequency signal sort of lines, get those to the connector. That's a little bit too close for comfort. Okay. And hopefully these are organized in a way that makes them as sort of easy to route as possible. They're all in sort of left to right order. I'm pretty sure we spent some time sorting that out last week. I just can't quite remember. We haven't. There's enough room to run a via in there, so we're going to run it there under the chip instead. So there we go. All right, just move that away from the pad a little bit more. I try and keep that sort of much distance between vias and pads, just to make sure there's no, that solder paste doesn't get in there and it doesn't all get sucked down into the via and cause soldering defects from not enough solder. Seriously, why won't you just put that via where I want you to, Eagle? Just put it there. Thank you. Righto. We are going to route it down to there. Lovely, lovely. Again, this last one, I'll just, while I'm here, I'll go from bottom up. Oh, hang on, we want going to the bottom. And now I notice we are short a decoupling cap on pin 10. That has me a little worried that we've missed something somewhere. I think that's meant to have its own decoupling cap and one of the others shares it. Honestly, at this point, I don't think it's going to be the end of the world because it's going to get decoupled right to that ground plane and there's enough capacitance around it. I think we're just sort of going to wing that one. Probably not ideal, but I don't want to have to rearrange all these traces to make room for a decoupling cap in there. And we've got really good decoupling on everything else, so I don't think that's going to cause us any concerns at all. And our power's just down there. Supply should be rigid enough. Righto. What have we got? Our foot switch 1 line. Actually, we've got this LED R and LED L signals that we need to get out of the way. Oh, some smoothie. Thank you. Okay. Oh, that needs to run all the way up there, doesn't it? I'm going to leave that one for the moment. I think it's probably sort of going to have to go down here and out and around to keep it out of the way of everything. Okay. Then put a pause on there. Let's come back and get these last analog signals out of the way, and also kind of route the decoupling of filtering of these pots. So go some 16 thou traces. I'm going to put a VR nice and close to that capacitor there, like so, and just connect it up like that. And that's going to ensure that we've got a nice bit of filtering just with that that capacitor on the line there. All right. Starting to get to the pointy end of things here. I don't know whether we'll get all the routing done today and be able to put the order in for the board or not, but we're going to go pretty close. Pretty close. So things like this, for example, this 3.3 volt line, here's where we don't need to run a VIA just for that. We don't have a reset line for our Bluetooth module. Glad I picked that up. I don't know how that didn't come up in the ERC. The beaker's going to a test pad. Okay. Right. Anyway, quickly. We don't need to run a separate VIA just for this 3.3 volt. Here, this sets the baud rate of the module. There's no need. We can just run that, kind of. Actually, I was about to say there's no need. We can just run it to there, but that's our analog 3.3 volt reference. They're going to the same ground plane, but I want to keep them separate where possible. So I am going to run a VIA just for that. After all, so bit of waffle. Okay, we've got this BLE and a reset line here that we haven't run. Where's a nice convenient place to do so? Not really anywhere. 37. I think 37 is going to be not sort of cause us too many headaches there. Call that. And this is going to allow our it's going to allow flip the microcontroller to reset our MIDI module, like just kind of reset the power state so that it can be, if we need to. I haven't really worked out exactly whether we'll need that or not, but I'd rather have that line available and be controllable than not have it, really. So I'm going to run this up kind of with the rest of, that was pretty poor. With the rest of these particular lines, just keep them all grouped. Right down here, again going down to our 6th hour trace and popping back up to an 8th hour. A little bit close. Bit close there. Okay, just give ourselves a bit more space. How are we doing? All right, time to change these to some 6th hour traces because we are not going to fit them all. That's for sure. That one, yeah, it's probably going to need to get changed as well, I'd say. This toggle B line. I'd like to leave that PWM as it is if possible. Let's see how much room that gives us. Should free up a little bit. We can move that up there a bit, given, yeah, these are very sort of high-speed digital signals. Okay. It's not too bad. I don't hate that. Oh, let's route that up from here and see how we go. Yeah, plenty of room. Plenty of room. No issues at all. Lovely. Perfect. And in fact, we can change these. Get that out of the way. We can change that back to being a 6th-hour trace after all. Fantastic. All right. Let's save that. All right, we'll save that. We might call it there. It's going to be a little bit of a shorter stream today, so just over an hour, because I've got some solder paste that has come to room temperature nicely, and I need to go in and run some MIDI through gizmos, which actually I've got a finished board here. I haven't really showed this on camera before, apart from some photos, but it's still got some of the rail pieces on, but the nice purple, I'll switch to a full width camera, purple and Enig finished PCB, and it looks really nice in this purple, which was done to help with the reflow process, but I think visually it's obviously not showing up on this pretty crappy little webcam at all, but especially in the laser acrylic case, this is terrible. It looks so much better in person, but this thing really does look smart. It looks so nice. So yeah, got to get running through those and get some orders out the door. So that's all for today, folks. Thanks for tuning in. Next week we'll be finishing the routing and ordering these boards and getting them sent away, and then it's on to firmware, which should only take us a week or two. So that's all for now. Enjoy the rest of your day. See ya.